Okay, I'm going to go over the stuff that happened yesterday because in our class the WebEx did not work. So if you were in class on Wednesday, which was the 2nd of September, you do not need to come back. This is kind of going to be at least going over most of the class notes that we covered on 9-2-20. And I may not use the exact same examples, but it'll be fairly close. You can start for those of you who are there, you can start with the examples of the graphs because that's where we picked up, and I kind of went through and did some more work on that first one. But for the rest of you, let's kind of go over some of the stuff that we looked at. We were looking at limits at infinity, and we said for limits, we have several ways with which to evaluate them. We first off have direct substitution. And I'm going to abbreviate that DS just in case you see it. And no matter what, we always try that first. If that doesn't work, we can try our factoring. Next, we can try a conjugate, assuming that we have the two terms, one of which is a square root. If we have a one-sided limit, we can try a numerical approach. And we're going to add one to that today, and this is going to work for limits at plus or minus infinity. When we see those, what we can do here is divide each term by the highest power of x. And then finally, of course, we have our limit property that we have seen, and that is the limit as x approaches 0 of the sine of x over x. And so today we're going to concentrate on looking at these limits at infinity so you can see how they work. The first example I did in class yesterday had two parts to it, and it was the following. Let's look at the limit as x approaches, sorry about that, positive infinity of 1 over x versus the limit as x approaches negative infinity of 1 over x. And we'll start with the positive one here on the left. So this is one of those things, kind of like the numerical. You can actually take out your calculator and give this a try. What we're going to do is we can't actually get to infinity, but we can pick a value that's really, really as close as we can get. Something like, I don't know, maybe 100 million, or that would be 10 million, wouldn't it? 10 million, 8 zeros. And if you put that in a calculator, what you're going to get is a very, very small number. And actually what you're going to get is a number that is essentially 0. And so we're seeing something a little different than we saw the other day in class. The other day in class, we saw that if we took any number and we divided it by a really small number, that gave us positive or negative infinity. Now we're seeing if we take any number and we divide it by a really large number, we're going to essentially get 0. And it really doesn't matter whether it's positive or negative. Look at what happens on this other one over here on the right. On this one, I might put in a negative 10 million. And I'm still going to get a number that's like 0.000000001. It's going to be a negative, but it's still going to essentially be 0. So whether that bottom is getting really large positively or really large negatively makes no difference. As long as we have a really large bottom, that thing is going to go to 0. Okay, so then I went through and I did some examples with this type of thing. And I'm not sure if these are the same ones I did in class. Remember, the notes for class are always out there if you want to go back and look at them. But I'm just going to pick some things and just kind of give it a try here, and let's see what happens. Let's try the limit as x approaches infinity of 3x divided by 7x squared minus 2. Now, the first thing we're going to try to do is a direct substitution. In a direct substitution, I would get infinity on the top and infinity on the bottom. And it's important that we understand that infinity over infinity, just like 0 over 0, are what we call indeterminate forms. meaning we cannot tell. We can't use what information we have to tell us anything. We can't guarantee those are equal to 1 or 0 or anything else. We don't know. That's what indeterminate means. So we got to figure something else out. When I look at this problem, I think about factoring, but even if I could factor that denominator, it's not going to help me any. I'm not going to be able to get rid of anything. There's definitely not going to be a conjugate situation because I don't have a square root. As far as numerically goes, those really only work with one-sided limits because we've essentially done a numerical thing. We picked a number as big as we could and got it in indeterminate form. So what we're going to do is we're going to come in here and we're going to divide each and every term by the highest power of x. That is, we're going to look at the limit as x approaches infinity of 3x over x squared, since x squared is the highest power in this, divided by 7x squared over x squared minus 2 over x squared. And then I'll do the cleanup on that because some of those x's are going to cancel. This is going to give me the limit as x approaches infinity of 3 over x divided by 7 minus 2 over x squared. And anything in this, folks, that continues to have an x in the denominator then becomes, when I put infinity in, a number divided by a really big number. And as we just saw, those values are going to go to 0. And so we get 0 divided by 7, which is 0. That's a perfectly valid value for a limit. You can get 0. We can approach 0 from the right and the left, so that's a perfectly good value when we're doing this. Okay. On the next example, let's try something like, I don't know, I'm going to make something up here. Let's do the limit as x approaches infinity, and let's do 5x squared divided by x plus 1. All right, once again, if I were to do a direct substitution, I am going to get that infinity over infinity, which tells me I have an indeterminate form. I cannot do any factoring, conjugate, numerical, or anything else, but I do have a limit at infinity, so I am going to come in here and I am going to divide each and every term by the highest power of x, which is once again an x squared. So I'm going to have 5x squared divided by x squared, x divided by x squared, and 1 divided by x squared. And guys, by the way, we can do this because that's no different than taking the top of this and multiplying it by 1 over x squared and taking the bottom and multiplying it by 1 over x squared. And remember, we're allowed to multiply by 1. That works out the same as if we just go ahead and divide each and every term by x squared. So just so you know where that's coming from. Let's go ahead and clean up the x's here. This is going to give us the limit as x approaches infinity. I'm going to get 5 divided by 1 over x plus 1 over x squared. And anything that gets a x still in the denominator is going to go to 0. So we're going to get, actually in this case, 5 over 0, and we cannot divide by 0. Now this is not an indeterminate form. This is a very specific form. This tells me that this limit does not exist. That's different than getting 0 over 0. 0 over 0 is indeterminate, meaning we don't know. But when you get a number divided by 0, that's just flat out 0. Let's do one more of these. Let's try the limit as x approaches infinity. And by the way, these could be negative infinity. It's not going to make any difference because we're still going to wind up with the same thing. Let me show you what I mean here. Let's take 4 square root of x plus x cubed. No, let's just do plus x. Let's just do plus x here. Sorry about that. Get my eraser and get rid of that there. Okay, just by x there. Divided by 3 plus x to the minus 3. Okay, now you see this right here? When I do this and I write that for what it really looks like, what that looks like, folks, just so you know, make that a 3x too, by the way. I just needed a little more x's in there. 3x, and this is going to be 1 over x cubed. No matter where I'm at in doing this problem, as soon as I see a single fraction that has an x in the denominator, I know that that term is going to go to 0. And I can get rid of that at any point in time in my limits to positive or negative infinity. because even if I come through and divide by the highest power of x, all that's going to do is put more x's on the bottom of this one, and it's still going to go to 0. But if I look at what I have left, I still have an issue because I'm going to get negative infinity over negative infinity, and it's the same thing. It's an indeterminate form. So taking what I have left, I'm going to divide by the highest power of x, and what's the highest power of x here? Well, it's simply x. So I'm going to have 4 square root of x over x plus x over x divided by 3x over x. And these two, well, the x over x just becomes a 1, doesn't it? It absolutely does. The 3x over x just becomes a 3. But what happens to this term right here? And this term right here is going to wind up leaving us extra x's on the bottom, and this term is going to go to 0. And I'll show you that in a minute. So when I put in the infinity for x, I'm going to wind up with 0 plus 1 over 3, or 1/3. And I showed him this in class, and I'm going to show you as well. When you have something like 4 square root of x over x, there are 2 ways to look at this, and I'll give you both of them, and you pick one that makes sense. You can think of x as being the square root of x times the square root of x. That's a true statement, because if I multiply those together, the square root goes away. And so as long as things are being multiplied, one of those are going to cancel, and I'm going to wind up with a 4 over the square root of x. Now, that's, if you can just kind of see that, that's great. If not, what we're going to do is we're going to treat this the way we do other things with exponents. I'm going to write this as an x to the 1/2 divided by an x to the 1st. Now, let me come down here at the bottom and show you something. And tell me if this makes sense, so we can come back up here and do this one. If I have x to the 5th over x squared, most of you can look at this and tell me that I'm going to get an x cubed. And I will. But what's actually happening is you're first off going to where the most x's are, which is on top, and then you're taking that top exponent and subtracting the other one from it. And that's how you actually come up with the x cubed. If the situation were reversed and I have an x squared over an x to the 5th, it is still going to wind up having an x where the bigger number are, tops never disappear, they become a 1, and you just do the subtraction there, and you're going to get the 1 over x cubed. And it works that way every single time. So looking back at our example, the 4 is going to stay where it is, but notice that there's more x's, or the x's on the bottom, more of them than on the top. If I only have a 1/2 on the top and 1 on the bottom, there's more on the bottom. So I'm going to take a 1 minus 1/2 on the bottom, and that's going to give me 4 divided by x to the 1/2, which is the same thing as 4 over the square root of x. So again, we could see how when we took the limit of that, that would go to infinity.